The following questions will help you with your MyLab questions for Chapter 12. So let's get started. Determine whether the following statement is true or false. A plus b in parentheses squared equals to a squared plus b squared, and a minus b in parentheses squared equals to a squared minus b squared. Well, these are false statements. And they're false statements simply because when we're squaring a binomial, we take the binomials and we multiply those binomials twice. So that's a plus b times a plus b, a minus b times a minus b, and we'd end up with a trinomial term. But we can also prove this when we take two numbers and represent those two numbers for a and b. So for example, a is 4 and b is 2, and we square those numbers. We will add inside first 4 plus 2, which is 6, and we square that, and that equals to 36. Conversely, if we were to take the 4 plus 2 for our a and b, and square the 4 and add it to the squaring of 2, that will equal to 16 plus 4, which is 20, and this is a false statement. The expressions -4 squared and a -4 in parentheses squared each simplify to what value? So being very careful with these two expressions because they are very different. The first expression, we're only squaring the base, which is the +4. The negative sign is not connected to the exponent of 2. So we keep the negative sign, we're squaring the 4, and of course 4 times 4 is 16, therefore we end with the answer of a -16. However, when we're squaring a -4, the -4 is the base because it's in parentheses. So a -4 times a -4 will equal to a +16. The expression 3 to the second power times 3 to the third power simplifies to what exponential expression? So if we were to take the expanded form of multiplication, that means that we take 3 squared, which is the same as multiplying 2 3s, 3 times 3, and we multiply that times 3 to the third, which is the same as multiplying 3 times 3 times 3. We see that we end up with 1, 2, 3, 4, 5 3s, and that simplifies to 3 to the fifth power. Simplify the expression 4x in parentheses to the third power. So again, the base is the 4x, the exponent is the 3. So we are multiplying 4x 3 times, and 4 times 4 times 4, of course, is 64, and x times x times x, that means that we have 3 x's. That gives us x to the third. So the answer is 64x to the third. Select the answer that best completes the given statement. In the expression b to the n, of course, b is the base of the expression, and n is the exponent. Select the correct answer that completes the sentence below. The expression b raised to the 0 power is equal to 1 for any non-zero number b. And here's a quick example that applies this definition. If I raise x to the 0 power, that will equal to 1. If I raise x to the first power, that equals to x. For this next question, we're given a to the m times a to the n. This represents the definition for the product rule. And the product rule states that when multiplying expressions with the same base, as in A and A, we keep the base and we add the exponents. A to the m power raised to the n power represents the power rule, and the power rule states when raising a power to a power, in this case a to the m raised to the n, we keep the base, in this case it's a, and we multiply the exponents. For number 9, we're going to simplify the expression, and we're going to use the product rule in order to simplify this expression. And the product rule states, when multiplying expressions with the same base, we keep the base and add the exponents. So in multiplying 8s to the 5th times 6s to the 4th, we multiply the numerical coefficients the same way we would multiply any numbers. 8 times 6 is 48. Since the base of the exponents are both s, we're applying the product rule here. We have s to the 5th times s to the 4th. We keep the base, which is the s, and we add the exponents. And of course, 5 plus 4 is 9, leaving us with our final result. Write a simplified expression for the area of the following figure. So the area of a rectangle is equal to the length times the width. And of course, the length would represent the longest side of a rectangle and the width the shortest side. So we're multiplying 8x squared times 6x squared. So of course we're multiplying 8 times 6, those are just the numerical coefficients, and that equals to 48. But when we multiply x squared times x squared, remember we are applying the product rule here, which means when multiplying like bases, we keep the base and add the exponents. So this would leave us with 48x, and adding our exponents, 2 plus 2, that will leave us with the x to the 4th. So 48x to the 4th is the answer, and that is in square units. Write a simplified expression for the volume of the following figure. The volume is equal to the length times the width times the height. So we have the length, which is the 7x squared. The width is 3x squared, and the height is x squared. So we are multiplying 7x squared times 3x squared times x squared. So using the product rule again, when multiplying like bases, we keep the base and add the exponents. So first we'll multiply the numerical coefficients. 7 times 3, and we can consider the numerical coefficient for x squared as 1. So 7 times 3 times 1 is 21. And now we're multiplying the x squared times x squared times x squared. So keeping with the product rule, we keep the like base, which is x, and we add the exponents. So 2 plus 2 plus 2 is 6. So 21x to the 6th power is the answer, and that's in cubic units. What is the degree of the polynomial? So first, let's look at each term of the polynomial separately and discuss the degree of each of the terms in the polynomial. So we have a -2, that's a constant term, it does not have a variable. So the degree of a -2 is 0. For the next term, we have x, which is simply a 1x to the first. So that's a 1 for the exponent, therefore the degree of x is 1. For -x squared, that is a -1x squared. It has the exponent of 2, so the degree of x squared is 2, and -4x to the 5th has an exponent of 5, and the degree of a -4x to the 5th is 5. The degree of the entire polynomial will be the highest degree of one of its terms. So in this case, 5 is the degree of this entire polynomial. So I would select E in this case. Select the answer that best completes the given statement. A monomial is a number, a variable, or a product of numbers and variables raised to a natural number power. Or is it a polynomial? That is a number, a variable, or a product of numbers and variables raised to a natural number power. In this case, we'll select a monomial, because a monomial can be a number, such as a -2. It can be a variable, or it can be the product of numbers and variables. Select the correct choice that completes the sentence below. A polynomial is a monomial or a sum of monomials. The degree of a monomial is the sum of the exponents of the variables. The degree of a polynomial is the degree of the term with the great degree. And this should read greatest degree. A polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. Two monomials with the same variables raised to the same powers are like terms. To add two polynomials, combine like terms. Polynomials can be added horizontally or vertically. Give the coefficient and degree of the following term. 4w to the 5th power. 4 is the coefficient of the term, that's the numerical coefficient, and the degree of the term is 5, since 5 is its exponent. Give the coefficient and the degree of the term. We have a negative mn to the 3rd power. Since it's a negative sign in front of the mn to the 3rd power, but you do not see a number there, it's always assumed that there will be a 1 where there's no number present, but in this case, it's -1. So the coefficient is a -1, and being careful, the degree of the term will be a sum of this exponent. So in this case, we have two variables. This will be m to the 1st power, and this is, of course, m to the 3rd power. Adding 1 plus 3, the degree of that term is 4. Determine whether the expression is a polynomial. If it is, state how many terms and variables the polynomial contains. Then state its degree. So the expression is a polynomial. The expression is a polynomial. And the polynomial has 3 terms and 1 variable. And its degree of the entire polynomial is 2. And the reason why it's 2 is because we have 3 separate terms. The first term has the degree of 2, the second term has the degree of 1, and the last term has the degree of 0. So in order for us to find the degree of the entire polynomial, we always look for the term that has the greatest degree or the highest degree. And in this case, that is 2. So the degree of the polynomial is 2. So for the next several questions, we'll be adding and subtracting polynomials. I'm going to show you a method called the column method. It's a very good method to use when you are adding and subtracting polynomials and you want to go back and check your answers. So for this first question, we have 3x squared plus 6x plus 9 in the first polynomial. So I'll write all the terms vertically in a column, like so. For the next polynomial that we're adding, we have 6x squared plus 8x. So I'm going to line up the last 2 terms in a column so that they are lining up with the correct like terms. So we have 6x squared that will line up with the 3x squared, and I have a positive 8x, and that lines up with the 6x. Since I'm adding, I'll place addition signs between the like terms, and the 9 is not going to be added to anything other than a 0, so I'll place a 0 there. So when combining our like terms, we only combine the numerical coefficients. So 3 plus 6, of course, is 9, and we keep the x squared because that's the like term. We have 6 plus 8, which is 14, and we keep the like term x, and of course 9 plus 0 is 9, leaving us with the final result as 9x squared plus 14x plus 9. So for the next one, I'm going to use the column method as well. I'll be lining up the 3p to the third, the positive 2p squared, and the negative 1 in the first column. And then I'll line up the like terms from the second polynomial here. 2p to the third lines up with the 3p to the third. The negative 2p does not have a like term, so it's not going to line up here with my 2p squared. And then the positive 2 will line up here with the negative 1. Since I do not have a like term to subtract from with the negative 2p, I'll place a 0 here. And I do not have a like term also for the 2p squared, and I will place a 0 there. So we are adding like terms, so I'll place my addition signs here, and then we'll go ahead and combine our like terms. So we have 3p to the third plus 2p to the third. 3 plus 2 is 5, and that's p to the third. I have 0 plus a negative 2p, so that's just going to leave us with a negative 2p. And 2p squared plus 0 is 2p squared. And a negative 1 plus 2 is 1, leaving us with 5p to the third minus, well, and let's put this in descending order. I'll say plus 2p squared minus 2p plus 1. And then the next one is already lined up into column form, essentially. But what we'll do here is we'll place a 0 here for the negative 3, since there's no like term. to combine. And we have a negative 9x squared plus 2x squared, which is a negative 7x squared. We have a positive 7x plus a negative x, and that's the same as a negative 1x, which is a positive 6x, and then 0 plus a negative 3 is a negative 3. So the next question is already lined up for us with addition, so it'll be easy to add our like terms. I'll place a plus 0 here to represent the like term to combine with the negative 1. And we have a negative 6x squared plus 4x squared. So of course negative 6 plus 4 is a negative 2. And that's negative 2x squared. We have a plus 1x plus a negative 4x. So that's 1 plus a negative 4, which is a negative 3. And we keep a like term, which is x, so that's negative 3x. And 0 plus a negative 1 is a negative 1. Write the opposite of the polynomial. We have 50x to the third, and of course the opposite of that is a negative 50x to the third. And for the next question, let's use the column method here as well. So we'll take the negative 8x squared and the positive 6x and put that in the first column. For the second polynomial, I'll line up my like terms. So I have an 8x squared, which is a positive 8x squared here. I will line up the positive 8x and then place my negative 2. Now, I do not have a like term from the first polynomial for the negative 2, so I will place a 0 there. We are subtracting like terms this time, so this is a subtraction question. So I'll place my subtraction signs, and let's go ahead and subtract our like terms. So a negative 8 minus 8, which is a negative 16, and so that's a negative 16x squared. 6 minus 8 is a negative 2, and we have our like term x, so that's negative 2x, and 0 minus a negative 2 is a positive 2. So the final answer is negative 16x squared minus 2x plus 2. And we'll do the same for the next example. We have zx to the third minus 2z squared minus 3z. For the next polynomial, I will line up my positive 7z squared with my negative 2z squared, the positive 8z with a negative 3z, and I have a positive 6 here. So for the z to the third, I'll place a 0 to represent that missing like term, and down at the bottom here, I'll place a 0 in order to represent there's no like term for that positive 6. So this is another subtraction question, so we're subtracting our like terms. So I'll place subtraction signs, and we can go ahead and combine our like terms. So z to the third minus 0, of course, is simply just z to the third. Negative 2 minus 7 is a negative 9, and that's z squared, so negative 9z squared. Negative 3 minus 8 is a negative 11, and we have our z, which is our like term, so negative 11z. And 0 minus 6 is a negative 6. Leaving us with the final answer for z to the third minus 9z squared minus 11z minus 6. So pause the video, complete number 32, and when you restart the video, you will see the answer. Your answer should be a negative w to the fifth power plus 14w squared minus 15. For the next question, your answer should be negative x squared minus 3x minus 7. Find a polynomial that equals the area of the figure to the right. Calculate its area for x equals 18 feet. So this is the figure, and we have a large rectangle and a small rectangle here. So of course, the area of a rectangle is the length times its width. So for the first rectangle, which is the largest one, we are multiplying 2x times x, which is 2x squared. For the second rectangle, this is the smallest one, we are multiplying x times x, and that is x squared. So to find the area of the entire figure here, we are going to take the area of the first rectangle, which is 2x squared, and add it to the area of the second rectangle, and that is x squared. So again, be careful, we're not multiplying, we're combining like terms, and that will give us 2 plus 1, because that's the numerical coefficient of the x squared, 2 plus 1, which is 3, x squared. Now, we're going to calculate its area for x equals to 18. So we're going to take the 3x squared, plug in where x is 18, and simplify from here. So we have 3 times 18 to the second power. So we're squaring 18, and 18 squared is 324. And 3 times 324 is 972. And the units are in feet, so that's 972 feet squared. Write a polynomial that gives the area of the rectangle. Calculate its area for x equals 2 feet. So in order to do this, we must calculate the area for both rectangles. So let's start with the smallest rectangle. We have area equals the length times the width. We have 3x times x, and that equals to 3x squared. And then we're going to find the area for the larger rectangle, length times width, and we have the same here, right? We have 3x times 7, and that's 21x. So the polynomial that gives the area for the rectangle is 3x squared plus 21x. So we're going to find the area for x equals 2 feet using 3x squared plus 21x. We replace or evaluate the expression using 2 for x, like so. And we have 3 times 2 squared, of course 2 squared is 4, and 21 times 2, which is 42. So that's 12 plus 42, and that equals to 54 square feet.